Hi, this time I'm looking at the Unit 3 Practical Skills booklet, Practical Booklet B for Higher Tier GCSE Chemistry. It's 1 hour long and the total mark for this particular one was 70. So let's have a look. So N2CO3 here represents a carbonate containing an unknown metal M. A solution of the carbonate was prepared by dissolving 10.98 grams of the solid in water, making it up to 1 dm cubed, 1 litre. So 25 cubic centimetres of this solution were transferred to a conical flask and titrated with 0.2 molar hydrochloric acid until the reaction was complete. So the table below shows the results of the titration. You see here we have the rough titration here, and then the accurate ones 20 and 19.8, and then we have the equation for what's happening. So M2CO3 and 2HCl gives 2MCl, H2O and CO2. So probably important to note that the formula here is M2CO3. Describe with due regard for safety and accuracy how you would transfer exactly 25 cubic centimetres of metal carbonate solution to the conical flask. Specialist scientific terms question, communication. So you would have to write in, fairly logical, sequential way and use the correct words. So use a pipette, fill it with a safety pipette filler, rinse the pipette with the metal carbonate solution, fill it to the bottom of the meniscus line, release it into the conical flask, and then touch the pipette on the surface of the liquid. So if you're hitting 5 to 6 of those points, you're getting 6 marks. 3 to 4 is 4, and at least 2 would give you 2 marks. So nothing there for just 1. And it says the average titer was found to be 19.9. Calculate the number of moles of hydrochloric acid used in this titration. So the formula you're using, N equals mv over 1,000. So M is 0.2, that's the concentration. The volume is 19.9. 1,000 is always 1,000. And then that gives us 0.00398 moles. So you see 1 for substituting in the values correctly and 1 for working out the value correctly. So use the balance symbol equation to deduce the number of moles of metal carbonate present in 25 cubic centimetres of the solution. So it's a 1 to 2 ratio here. So we have 0.00398 divided by 2, which gives us 0.00199. Then calculate the number of moles of metal carbonate which were present in 1 dm cubed of the solution. So 0.00199 divide by 25 times 1,000, which is 0.0796. Or some of you may know that to get from 25 cubic centimetres to a litre, you just multiply by 40, and that is acceptable to do that in that calculation too. So using your answer to part 3 and the initial mass, calculate the formula mass of M2CO3. So we have 10.98 divided by 0.0796. And of course that is what we've just worked out, and the initial mass was 10.98. So that gives us 138 as your formula mass. So then use your answer to part 4 to calculate the relative atomic mass of metal M and identify the metal. So I've just worked out here that carbonate is 12 for the carbon, 3/16 for the oxygen. So 12 plus 48, which is 60. So 2M is 138. Take away that 60, which is 78. So the relative atomic mass of M is 78 divided by 2, which is 39. Then the identity is potassium. So you look it up. Relative atomic mass of potassium is 39. Number 2, hydrated nickel sulfate, which is NiSO4.xH2O, was placed in an evaporating basin and heated to constant mass. State what's meant by heated to constant mass. So heat and weigh it for your first mark until the mass doesn't change for your second mark. Then draw a labelled diagram of the assembled apparatus used to heat this nickel sulfate to a constant mass. Now I thought that was a bit nasty, because when I've done this in class I always would use a crucible to carry out this experiment, but it says use an evaporating basin. So they were looking for the solid in an evaporating basin. That was for 1 mark. Second mark was for having a gauze and a tripod in there, and the third mark was for showing that you're heating it. So it had to be a labelled diagram like that. And make sure you read the question carefully, because that was just a bit tricky of see, I thought. Part B, a sample of hydrated nickel 2 sulfate was placed in an evaporating basin and the following measurements were made. The mass of the evaporating basin was 45.12 grams. The basin and the hydrated nickel sulfate 50.38. The basin and contents after heating to constant mass was 48.22. Calculate the value of X in the nickel sulfate.XH2O. So the first thing you do is you work out the mass of the anhydrous nickel sulfate, which is 48.22 minus 45.12, which is 3.1 grams. Then you're working out the mass of water, so 50.38 minus 48.22 is 2.16. And then the mass of the anhydrous nickel sulfate, so is 3.1. The number of moles of the anhydrous nickel sulfate, the mass divided by the formula mass, so 3.1 divided by 1.5, which is 0.02 moles. The moles of water, again, number of moles is mass divided by the formula mass, so 2.16 divided by 18 is 0.12 moles. And then we make a ratio for the nickel sulfate to water, and that's 0.02 to 0.12, and we divide through by the smallest number, which in this case is the 0.02. That gives us 1 and 6, so it's a 1 to 6 ratio, so X is equal to 6. And you'll see there are 7 marking points here, or 7 points for working out the different parts. So there's 1 here, 2, 3, 4, 5. That would be 6, and the 7th one, I think, is just for this ratio of moles. Okay, describe how you would experimentally prove that solid nickel sulfate contains sulfate ions. The first thing you need to do, because it's solid, is dissolve it in water. Then you would add barium chloride solution, and remember you have to say solution, and then it gives a white precipitate if the sulfate ion is present. So 4 marks here, 1 for dissolving it, 1 for with the barium chloride solution, 1 for the white precipitate if the sulfate ion is present. Next, sulfuric acid reacts with zinc and or zinc carbonate to form zinc sulfate solution. Write a balanced symbol equation for the reaction of zinc with sulfuric acid. So Zn plus H2SO4 gives ZnSO4 and H2. Because any metal reacting with acid will give hydrogen gas. Observations, any two of these now when zinc reacts with sulfuric acid, so bubbles are fizzing, the zinc disappears, you get a colourless solution formed, and heat is released. Now we have a flow chart showing the steps in the preparation of hydrated zinc sulfate, which is ZnSO4.7H2O from zinc carbonate and sulfuric acid. So step 1 is measure 25 cubic centimetres of acid, place it in a conical flask. Step 2, add the zinc carbonate until it's in excess. Step 3, filter to remove excess zinc carbonate. Step 4, heat the filtrate until the volume is reduced by half, then allow to cool and crystallise, and then filter off the crystals and dry them. So what piece of apparatus is used to measure out 25 cubic centimetres of sulfuric acid in step 1? Well, measuring cylinder. I'm going to try and keep this so you can see both on the same. So how would you know that zinc carbonate is in excess in step 2? So it's in excess because some of it remains, and you can see that actually from step 3 that you're filtering to remove the excess, or you could have said that no more bubbles are forming. Then draw a labelled diagram of the assembled apparatus used to filter the mixture in step 3. So step 3, you're filtering the excess zinc carbonate, and then in step 4, which is next, you're heating it to reduce it by half. So what the mark scheme was looking for was your filter paper for 1 mark, your funnel for the 2nd mark, and then an evaporating basin for your 3rd mark. Now normally you would filter into a conical flask, and that's what I would expect to see, but here, because it's going to evaporate next, they've accepted evaporating basin. Right, then explain why the solution is not evaporated to dryness in step 4. So it's to retain the water of crystallization. If you heat it to dryness, you're going to lose that. Why do crystals form on cooling in step 5? It's because as the solubility decreases, as it gets cooler, the crystals then have to form the solute comes out of solution. So state two methods of drying the crystals. You could have any two of these. You could have had between pieces of filter paper, in a desiccator, or in an oven on a low temperature. Then write a balanced simple equation for the reaction of zinc carbonate and sulfuric acid. So zinc carbonate, ZnCO3, sulfuric acid, H2SO4, and then you're getting zinc sulfate, which is ZnSO4, plus carbon dioxide, plus water, and that's a nice one because it's already balanced. So 2 marks, 1 for the products and 1 for the reactants. Then describe how you would prove experimentally that the solution formed contains zinc ions. So you would add sodium hydroxide or ammonia solution, and then you get a white precipitate which forms. So 3 marking points there, 1 for adding the solution, 1 for white, and 1 for precipitate. Now we've got a solution of hydrogen peroxide is being used to sterilise some contact lens sterilising systems. Hydrogen peroxide decomposes into water and oxygen according to the equation 2H2O2 gives us 2H2O and O2. The hydrogen peroxide sterilises the lenses overnight. A disc of manganese 4 oxide or manganese dioxide is also present in the contact lens case to act as a catalyst for decomposition. So what is the formula for manganese 4 oxide? So when I do a formula, I like to use just valency. So oxygen's group 2, its valency is 2. Manganese here tells you is 4. So I draw arrows like this and I swap the numbers over. So I get Mn2O4, and if we simplify that, then it's MnO2. And that is the formula, MnO2. The student planned to monitor the rate of decomposition of hydrogen peroxide. So 40 cubic centimetres of 0.2 molar hydrogen peroxide and 1 gram of manganese oxide were placed in a conical flask which was sealed and connected to apparatus used to collect gas. The volume of gas produced was monitored over a period of 2 minutes. Draw a labelled diagram of the assembled apparatus which could be used to monitor the volume of gas produced against time. Include all the apparatus required to carry out the experiment. So we're going to need to measure every 2 minutes. So stopwatch for that. That was 1 mark. And then the apparatus for the experiment. So you had a conical flask here with hydrogen peroxide in it and manganese dioxide in it, and that all was worth 1 mark. A delivery tube going through from the conical flask to the gas syringe was 1 mark, and your gas syringe was also 1 mark. So you had a maximum there of 3 marks from any of those 4. Now I've got the results from the experiment at 25 degrees are plotted on the graph below. So what's the final gas volume obtained? So we're looking for when it flattens out. When you draw that line down here, you get 96. The final gas volume. I'm going the wrong way. It was this one here to begin with. Sorry, 96 cubic centimetres. And then the time the reaction stops at is where I've already drawn the line there. So apologies, did them the wrong way around. So, but that comes in at 112 seconds plus or minus 2. Using your graph, deduce the time at which half the final volume was collected. So half the final volume is 96 divided by 2, which is 48 cubic centimetres. And that then is coming in here at 24 seconds, and again, plus or minus 2. Then we have 4 organic compounds from different homologous series. A series of tests were carried out, and a tick indicates a reaction that occurred. So we've got tests of bromine water, sodium carbonate, and acidified potassium dichromate being warmed. What is observed when A reacts with bromine water? So the reaction has happened, so it's going from a red, brown, or orange solution to colourless. 2 marks for that. What's observed when C reacts with acidified potassium dichromate solution? So it's going from orange to green. And then what's observed when D reacts with sodium carbonate? So with sodium carbonate, it's going to be fizzing or bubbles for 1 mark, and the solid disappears for the other mark. And finally, it tells you A has the empirical formula of CH2, and its formula mass is 42. So what's the molecular formula for A? So working out the relative molecular mass there for CH2. That's 14, so 12 plus 2 is 14. And then we know that the mass is 42. Divide that by 14 gives us 3. So multiplying that CH2 by 3 gives us C3H6. Name A, so meth, eth, prop, it's propane. And what's the physical state of A at room temperature and pressure? Well, it's a gas. Which one's most likely to be an alcohol? So if we go back to the table here, the one which reacts with the acidified potassium dichromate here, which is C, is the one which is more likely to be an alcohol. And finally, name the products found, that should say formed, when B burns in a plentiful supply of oxygen. So that's carbon dioxide and water, the same as any hydrocarbon burning. That's the end of the practical B paper. Thank you for watching.